Good afternoon, everybody. Good afternoon to everybody who's joining. Every second I have people joining in. So I will do probably a welcome 2 or 3 times because I'll do a welcome now, then I'll do another welcome after another couple of minutes till have all the attendees on board. This is called a quarantine edition because everybody's quarantined at home. You can see behind me there's a hookah. So my quarantine is seemingly doing all right. Not that hookah has been touched. My name is Amit Malhotra. I am the co-founder of the Window and Facade magazine and WFM Media, along with Ahad, who heads ZAC. Along with that, I also run a group of companies by the name of McCoy. And I'm very, very delighted to host this seminar. This is the first webinar from WFM Media. I think I know that there are people from around the country here. Things are, I think from a global perspective, India, so far so good. Everything seems to be going well. The only question is what happens next is something that we can determine. But I think thanks to technology, at least we can continue to remain connected. And I think all of you in different businesses must be finding unique ways to keep yourself busy. Eat well, sleep well, drink well, if that is a choice that you would like to use, but religiously not too much every day. I do it every day. I have my friends catching up after 10:30, 11, and that's the way it goes. So we have 400 plus people who had registered for this webinar. At this point of time on my screen, I see about 150 odd people who are already connected. I will give it another couple of minutes if you guys don't mind to. Well, while I do that, let me introduce our distinguished guest of the day. The first guest of the day is my good friend, and I call him Mafia, and he calls me Don, but that's a relationship we have for last 14 years. Introducing Mahesh Arumugam. Everybody knows him. He's the regional director at Meinhardt Facade. He is an icon in this industry. Of course, he's not only that he provides his strategic leadership to Meinhardt Group and Facade Consultancy across South Asia. He's done a lot. Most of the nicer looking buildings which happen to be around our country and quite a lot in the world are designed by him. So he has expertise on glazing systems, precast concrete facades, to building integrated photovoltaics, BI LEDs, enhanced systems, everything to do with cladding. And he's worked across Asia, all regions, and in Africa, and of course in India for the last, I think, 13, 14 years with Meinhardt. So Mahesh, welcome. The second speaker that we have today is a young gentleman by the name of Bhami Ilyas. He is a BE and an MBA. He's the regional director of and the local rep out of Dubai. Bhami has over 12 years of experience in wind energy, experience, during which he's worked for iconic projects such as the UAE Pavilion, Creek Harbour. Oh, that's a beautiful building, the Creek Harbour. Kingdom Tower in Saudi Arabia, Sheikh Zayed National Museum in Abu Dhabi, the Chhatrapati International Airport in Mumbai, as well as numerous other projects in the Middle East and India. He's developed his career towards technical client service and business areas such as consulting, contract negotiations. Bhami holds a bachelor's degree in aeronautics from Anna University. So Bhami, good that you're not in airline for the moment, buddy, for the moment. And as a facility management from McGill, business management. Oh, he's too educated, man. Advanced management program. Gosh, I can't even read so much of education because I didn't end up doing so much of education for myself. So I just feel sometimes a little short. So don't get me wrong when I say all of these things. I was with my school group of friends a few days ago, from people who were in class 2 up till 10 together. And they were like, God, we never thought you'll ever end up making anywhere in life. They were doctors and so on. I said, tum log itne padhe likhe ho, to mujhe thodi si sharam aati hai. So anyway, without further ado, and let me, so we're at my fellow
no one can compare your education. You are a Harvard guy.
That's a different story. That was my need to want to, wanted to be noticed alongside with the other laureates like yourselves and our other colleague here, Bhami. So I said, let me finish. That's what my friends make fun of me of. That you are now, at least we are here. You were here. Now you at least come up till maybe here. So such is life. So would I request my co-host to allow the first presenter to start on building maintenance? Mahesh will talk about VMUs today. So should I kick it off?
Yes, Mr. Mahesh can start. He has the control.
Mahesh, over to you.
Yeah, okay. Thank you. Thank you for the good introduction and arranging this webinar, Amit. It's a wonderful thing you're doing in this COVID situation. Everybody are at home and at least they can spend time to experience all these. I don't know to say educate, but experiencing all this. So I start with my screen, good afternoon to all. Okay. The BMU access and maintainability of the facade elements, where we call it as a facade access system or building maintenance unit. So the system is very complex, depends on the complex structure and high rises, especially more than 40 meters is a very challenging, and human life safety is a key in this design and maintenance of these facades. So even for replacement, all is a risk basis. Sometimes the design should be always a manageable risk and should not end up with a non-manageable risk. So we are losing life of humans who challenge to work and maintain the facade and replacement or anything. See, the facade is like a which way you do is like a repair, periodical maintenance, and replacements of building of geometry to set complex facades or any shape. Today the trend is changing to complex geometries, not anything rectangular boxes. Access and maintainability, facade is like a car, cost and not maintenance free. You have to maintain periodically. Also, you have to maintain periodically maintenance. Then only can every 3 month cycles you can maintain the facade. Otherwise, this machine will become white elephant in any building. Regular maintenance is essential in any building, even including car. So I compare BMU as a car equipment. Car is also equipment. BMU is also equipment. Both the similarities operational. So that one difference is car is running on the road, BMU is standalone at the buildings. Access and maintainability, upkeep the facade appearance always important, because view from inside and view from outside always is give the landmark to the building, and always a good over a period it will become landmark to the respective areas or respective geographical locations. And also maintaining extend the lifespan of the building, and also regular cleaning and ad hoc replacements has to be done with the BME only for any high rise going more than 40 meters. Access and maintainability, look at the towers and the height and comparison of buildings, how in London, this is a London city looks. So solutions are varied depending on height and geometry, 0 to 50 meter, 50 to 100 meter, 100 to 20 meter, and 200 meter and above, now today gone to 1000 meters. Is a key to reach that space, and maintaining that element is not easy. High-rise buildings have specific limitations in terms of user requirement, timing, and weather conditions and everything, and trend of more complex building shapes, which is critical for any designing of any BME to reach to every nook and corner of that geometry, facade geometry. India still traditionally, you can see the buildings in India mostly coming like that, not any complex geometries like this. So globally, the trend is going to be complex geometry now. And access and maintainability, you need to have additional material costs or glass replacing units, and also the facade lighting and maintenance, if any facade integrated lighting, as well as opening proportions in facade for maintenance and access. Otherwise, you're not able to reach and maintain the facade elements. Also, replaceable is external features whenever you get damage. How to integrate the design into the building? See, this is one of the tower where this place is used as a cafeteria. At the same time, they use for a maintenance in a revolving tower in, I think, in Kuala Lumpur. So this system is completely essential part of planning and design for such a high-rise towers. This machine can reach up to 22 meters. The zip, you can see the telescopic of this cradle, and it's tiltable also. And it must be incorporated in the early stage of the design. Anything such a BME for any high rise, you need to start from the concept schematic stage to incorporate, because this machine sometimes heavy, loading reactions has to go to structural consultants. Sometimes this machine is become 20 tons, you never know. So you have to be extra careful. In any high rise, you have to take care of determining the BME system in the concept schematic stages. Regular cleaning and ad hoc replacements also planned in concept schematic stages. So also the integrated designs cover initial concept, as I say, BME, you have to zone it out. What are the systems? You see the color mapping, elevation mapping, which we always do to identify the system, what kind of system replace, and where our restraint sockets layout. You know, above 40 meter, you need to have a restraint sockets at every 10 meter height at the width of every BME systems. Otherwise, the BME cannot drop down from the roof terrace, is rattled through the wind, and maybe sometimes the cradle will rotate and lock, and you cannot evacuate the people. Then sometimes we need, in some cases, use helicopter to evacuate such conditions where there is no restraint locked. So additional design considerations we need to be addressed. Also, the integrated BME design, you need to, currently we are doing it most of the project with beam integrated systems. So is a roof space planning, because in the roof many things are coming out. BME equipments, MEP equipments, BMU, fire tanks, fire sprinkler tanks, many elements, AHUs, many things coming, cooling towers, all these. So this has to be properly planned in the upfront of the schematic stage. And how many systems, how is the geometry of the building, and you need to have this kind of analysis in the beam, where slope facade or how much zip length has to go. This all to be tracked and trolled around the roof terraces. And also, very importantly, you need to provide a water and power point at every 10 meter to 20 meter intervals for the BME equipments to scroll around and connect the water and power. So the roof space planning and MEP coordination is a key in concept schematic stages. Also, additional design consideration, you know, some kind of geometry is created like this, how we recess inside. Your hand is accessible to only 800 mm and only vertical 90 degree to the facade. So reaching 2 meters inside deep to the glass of any geometries, you need to have special consideration designs. Sometimes the cradle has to go between the skins, double skins. So the design should be integrated such a way that you have to do. And coming to even the slope roofs, you need to have a, as I said, is a car. We need to have some kind of glass wiper, you know, screen, windscreen wiper like that. We need to have a BMU to go on sloped facades to cover all elements. Look at this right-hand image. There's a two system. One is both sides. There is a rail coming down to for the sloped area. Also, there is a BMU to reach to this where the slope cannot come, because it's a cone type. Also, the full extended jib position, you can see this is about to currently about 22 to 25 meters jib length only available in the market as of done and executed jobs. So it should be full retracted jib position required for such a cantilever position. And also winch need to be attached. And the right hand side, you can see the yellow color rope, where is a soft rope integration also required for any geometries. Look at this left hand side image. The cradle started from left end of the building and come all the way transferred here with a soft rope. The soft rope is for restraint, because he has to lift up and go back, remove the rope and go back. How the way he comes down for cleaning and maintenance, the same way he has to go back because of the geometry of the building. The right hand side building is also in Delhi, which we did the project of facade and BMU, where there is also requirement of the extreme right hand job, the rotating, some kind of passive rotating tower design concept, wire required soft rope systems. So there's a lot of systems available in the industry. So you have to customize to the requirement of the geometry design. Look at this. These are the few restraint guidelines, Mullian guides, mullion to guide. You can integrate these 3 strains to mullions, some kind of guides, and some kind of soft rope, as I showed you earlier. So these are very complex. This is not like that even a facade one engineer cannot do that. This require a vertical transportation team and mechatronic and electrical team to completely review this BMU. Many people just getting some drawings and images, integrating and become white elephant. And the end of the day, people are going upselling and cleaning in it. So the investment gone to for nothing. Also, the integrated wherever the not able to reach the place, you need to have a hard to reach the locations. You need to have a articulated or arm expandable BMUs required, like hand sketches we did for the project. At the right hand side, you can see that. And also, you need to access door opening need to be provided to concealed access for door opening to access to the cradle or anything to enter and to operate the machines. Look at this door opening provided, but this aesthetical feature looks like red color, but whenever maintenance point of come, it can be opened and slide and open and can lock back. The project coordinate conditions to be considered, as I said, use of restraint guidelines required, and distance to facade is a very key in analyzing and design a system. Sometimes the distance gone 50 meters, or sorry, 50 feet means about 10-15 meters reaches inside. So weather conditions of maintenance required very carefully need to be addressed, and other environmental conditions, rain, sandstorm, seismic activity, etc. During this time, you should not do the maintenance. Citing all above, as I said, we need to see how many types of BME systems available in the industry, and this can be customized to the suiting requirements for any projects. Sometimes the twin track, like a train track, we need to provide at the rooftop to machine to travel all around the perimeter of the facades. So the cradle can be walked inside the roof itself, because you need a luffing to bring back the cradle back to the roof terrace to park in. And this kind of roof terrace systems will be expensive and safe and reliable. And this system can do a glass replacements. There's a 2 types. Sometimes the parapet is at 1.1 meter, then you can put the track on the RCC slabs. Sometimes the parapet is more than 2 or 2.5 meters, then you need to have a erect MS structure to track around this BMU. So you can see the both conditions on the RCC as well as the elevated tracks. Also, twin track, you can integrate the material hoist. You can lift the glass together with the cradle, and you can go and replace, or you can separately do a winch separate and cradle separate. It's all part of designs, so it can be operated from the cradle itself. And also for Davit, then some cases, the glass parapets come, then you cannot attach the Davit arms to the parapet, so you have to force to do it on parapet mounted. So this is another system. You can cantilever up to 4 meters. After that, beyond the Davit arm system will not work from envelopes. And floor mounted Davit arms, you can see these different types of brackets, sometimes concealed, sometimes exposed, which way you can do, but aesthetically you can cover and you can walk over the brackets. Whenever required, you can open the manhole like a manhole and put the davits, and you can work and close back. Still, you can use the access for the Davit arms. Also, this is a parapet mounted, I said. You can parapet mounted, you can independent brackets, or you can mount a rail on the parapet to traverse around the parapet to down the thing. These independent brackets, different types of independent brackets on the parapet. So also the monorail with the cradles, this can be projected out. So this also can be used, but this cradle, you need to rigging and de-rigging the cradle from the ground floor or any terraces, below terraces, to come up and go down. But you need to provide access at the parapet where the rigging and de-rigging required to just small opening to lock in the cables to the winch and the rail. So this as a limitations, up to 1900 mm only we can project it out. So monorail track types, there are different types. You can see, you can travel around the same perimeter of the facade or the geometry of the facade. So you can put all types of monorail systems into these buildings. Also, the other option up to 50 meters, 53 meters, you can do without a BMU on the building. You can get these cherry pickers or boom lift machines. There are few types available. Currently, the machines available up to 53 meters height, and it have a multiple luffing, maybe 90-degree luffing or multi-degree angle luffing is available in equipments. This is a multi-luffing angle. The earlier one is a direct vertical, only one luffing to go recess inside. This is a 3 stages of luffing. So you can get any geometry reach on the yellow color. And the right one is only 2 type of luffing. And again, the cherry picker boom machines you can use for interiors, but this you cannot operate them diesel fuel based machines because inside air conditioning smoke comes. So you are forced to operate this kind of scissor lift by battery operated or electrical operated, or you can use a Davit or upsell links. And also the eye-bolt system. The next system is a Davitom. You can provide for man to suspend with the safety ropes, mounted on the parapet. If there is no parapet mounted, then we can have this eye bolt, say type like this. You provide a 15 kilonewton tested as per BS 7985. You can put every 1.0 to 1.5 intervals, and people can come as upselling and cleaning. We can provide 2 ropes, one for suspending the dead load of the human, as well as the jerking load and safety rope can be additional rope can be added to this. These are the other aerial working platform for interiors. This can be different types up to 15 meter available now, 14 to 15 meters. So it can be folded and you can bring into the lift, service lift to reach to any level or any floors. The size is about 1 meter, 1.2 meter width by 1.8 meter. As long as the lift size accommodate this, you can take into the lift to inside any portion of the building for ceiling or air conditioning duct or filled air conditioning filters or ceiling lights, all replacement and maintenance can be done this. And also interior atrium facades internally, you can use this up to 14 meters. Then on wherever non-accessible area, equipments cannot reach or no provision to not able to provide, you can provide the access to these locations, and you can provide the safety line and polar systems. And where these lanyards and safety lines, you need to have a shock absorber, otherwise it will break the bone ribs and bones of a human if heavy impact or anything when he is stretching his body to reach the level. So normally this kind of safety line and Polaris system have one end have a shock absorber for the life safety of the maintenance people who is using this Polaris system. Another option is a tucker pole, is a cleaning pole where you can now is available again 15 meter height. You can pump soap and water through this, and you can clean and wipe and maintain. Then temporary glass replacement arrangements where there is no winches, permanent winch is not available. You can use a temporary winch or a Davit system to lift the glass with a counterweight, and you can use for temporary arrangements. Again, I said MEP requirements is a key. You need to provide power and water at every 10 to 15 meter intervals. You should not exceed 20 meters. So the water fluctuation, power fluctuation will reach the machine is a key to achieve the water pressure also. Facade maintenance and optimal BMU design, I give some kind of thought process and awareness that regular maintenance increases the facade life. If you not regularly maintain the facade, the lifespan of the facade life will be decreased because the sealant and the gaskets, everything to be clean from the dust and pollutions, and also say any insect formation happen inside the groove or anything should be cleaned and properly maintained. And also glass should be cleaned. Any external reflectivity glass or any glass, the glass may, if not maintained properly, due to this petrocarbon from the emission from the cars, maybe corrode the glasses. So also we provide a consultancy for all projects. Nearly we've done about 150 projects BMO system in India, and we provide a cost-effective solutions, and we provide a full consultancy from concept to completion stage, even testing and commissioning and defect liability period. Also, we do a holistic and proactive approach to maintenance and also EC replacement components. So, whenever you do skylighting You need to provide upselling hooks also required for such a complex replacements. Where you're not able to erect a scaffold or from the ground level, at least you can bring the glass from the roof side, and if somebody needs the underneath to maintain these facades. Look at this shape and geometry of this facade. So address this geometry with for maintenance during the design process. So it will, the projection and geometry of the building is very important, as well as the safety is the first priority. So whenever you're not done properly design or properly suspended load or you overload, this kind of more concealed monorail damage due to overloading or not properly bracket center distance not properly maintained, or installation issue or quality of workmanship, all this lead to life safety. So you look at this is the one accident happened and people died on this. So these are the failures. So proper monorail and system to be designed. Again, I'm repeating, safety is the first priority. You see the accidents happen, people died. This is a cradle collapse and fall down. So these are the issues. And sometimes you Google it, BBC, one of the worst BME accident happened in a videos. You can find it, how the machines blocked and unable to recover. So people are stuck in the roof BME cradles. So they put a design of integrating system is like a telescopic cradle where it stuck. There is no proper design, so it's stuck. So they are unable to recover, and the people still stuck there. So they use helicopter evacuate this. You can watch this video in the BBC. Again, this another accident happened in the short tower in London. The BME was stuck there, and they maintained and repaired. So proper maintenance, the BME system also maintained, the facade also need to be maintained. So this design should be followed accordingly for lifespan of the building. So the key important things where we are addressing for the stainless steel bolt, nut, washers, these lead to over a period, it lead to give a huge failure. That time you want to take out the machine and replace the bracket, all high cost. So whenever you design a BMU, use the right material, bimetallic corrosion, SS bolts and nuts, all properly designed and done. You see, look at this. They done a good galvanizing on the runners, but they put a base plate without galvanizing, and the bolt they put a SS bolt. The washer they put a GA washer. So all rusting and getting less lifespan beyond the design life period. So BME testing is a key. We do complete review in the post-construction stages. We review complete drawing thoroughly, and each and every components we check, because it's a life safety issue. We address the issues based on EN 1808 code and 7985. That is a world stringent code globally, and these codes spell out. Even America and other part of the world, China, Hong Kong, using very high-end BMUs, but Europe has not much buildings. But European code is stringent, and globally people are adopting European codes. Most of the machines and the hoists, like all type of hoists, traction hoists or other hoists, they all other types, drum hoists, they manufactured in tested in Europe under EN 1808 and EN 7985 codes. So better to follow EN 180, which is a stringent code as on date. So we review and tender documentation and specification, all we follow EN 1808 and 785 and other codes related to respective regions, whichever stringent. Also, we do a testing in factory, completely load test, operational test, mechatronics, everything we do in testing factories before ship to the site. And also we long travel limits, which we check, electrical cable reel limits, which we check multiple times, and ensure these should not stuck or locked during operations after installations. And also we do a load test together with the human, and also we do a without human also lifting and checking the counterweight loads on top of the human loads. So complete test required for BME equipments. Even you need to have pressure tests. So then this ensure that 100% test is done on the factory. Then machine can be brought to the site and installed. Then you can do on-site testing. So again, I'm saying the repeated maintenance of testing and maintenance of facade is like a car. So please ensure whenever you providing BMU to your projects, is require a periodic maintenance of the equipments as well as facade maintenance. There's a facade cleaning cycle is there for a 3 to 4 times per year. There's a calculation for it. How many depends on the type of machines and everything we install in the building. So we have also addressed this, and we provide during our design and documentation or tender documentation, we provide a user manual for the cleaning cycle as well as the equipment maintenance cycle. And we ensure that the vendor also adopt the same to follow and the spec and tender to comply and to erection of this machine, manufacturing and erection machine, and commission the machines. After commissioning, we recommend put the maintenance period after the defect life period at least 1 year. So the same contractor or fabricator of the BMU, he manufacture, test and install and maintain the facade, and you give another 1 year for a maintenance contract. So the machine will be fully operational. So so you can take over by the facility management team, or the same contractor can do continuous maintenance. So also they look at this integration to structural, architectural, pumping, drainage material need to address on the BMUs. Otherwise, whatever the dust or accumulated and spoil the aesthetics. So that's all. Thank you, because they given me half an hour. So they told me to stick on time. So I finished it at half an hour time. So we can, Amit or Aghat can move on to questions.
So Mahesh, thank you very much.
Thank you.
And of course, as we've decided that the question and answer session will be towards the end of the second presenter, so as to making sure that we can follow the sequence. I hope, I'm happy to tell you that we're almost 250 people here in the present situation, which is pretty decent. And without much ado, maybe I can give you a 1 minute break if anybody wants to go for a sanitary stop or anything like that, get some water. Although it was like half an hour. I wanted to share something with all of you. So please don't get me wrong in any way whatsoever. What is interesting in this webinar concepts is that it's short, it's to the point, and it's not going to be more than half an hour or 1 hour. So there is a better attention span, I guess, for everybody to attend, and only those will attend who would want to hear the subject. So I think what the team at ZAC and my WFM team are doing a brilliant job in trying to take this thing forward. And I appreciate once again, and thank you very much for joining in, and hope that this time, which you would have normally 4 o'clock would have been napping away, you're actually gapping away with the knowledge and trying to see whatever best we can do going forward in time. Let me also tell you that during this quarantine period, we are going to be doing webinars virtually every second day. So we have with ourselves a panel of about 300 of the bestest technical experts on the field. Like, for example, we have our good friend Bhami here in Dubai, who's going to talk about wind engineering and air quality. So like Bhami, like Mahesh sir, we have a lot of people from around the world who are now interested to use this time. So I think what is positive is that you'll be able to get to learn a lot more sitting at home. And these presentations, I think my colleague will talk about it, whether we are sharing them or not at the later stage. I think some people have asked this question, so we'll answer that in the question and answer session time. So going forward, I now hand it over to Bhami Ilyas, who has more than 12 years experience. I introduced him in while we are starting. So without much ado, we are going pretty much on time. So Bhami, over to you, my friend.
Thank you, Amit. Thank you, Amit and Nahad, for having me on this program. It was nice hearing you speak, and also it's good to be spending time on a radical session like this with all of you. So today what we have here is, in case if the net is slowing down or so, I'll just cut off the video, sorry, my webcam, or also just show, so you can all see the slides well and clear. I have a few video slides as well. So the topic today, what we have chosen, is understanding wind effects in urban development for facade pressures. Now, understanding wind effects is a key matter of fact with regard to urban development. When you look at it in a very holistic sense, and when you try to put in much of a thought process into it, we are all designers one way or another, and we are part of this web process between developers, architects, structural engineers, and all working together, facade consultants, all working together to achieve a valuable design process for our clients. Now, before we step on to understand some of the thought process in the wind tunnel process of facade pressures, let me take you to codes and standards. So understanding codes and standards is a pretty interesting process, because codes and standards are very particularly has a lot of limitations in the process, because when you look at it, when you talk about the ASC code, or when you talk about the NBCC code, when you talk about the IS 875, the Indian Standard Code, it does not account primarily with regard to the conservatism. So the loads, the code standards has a lot of limitations in general, because they're conservative. And we also need to be aware that these codes and standards does not apply to unsymmetrical geometries, because now and then, always what we see is architects come up with all kinds of design processes and shapes and forms where we need to understand the loading structure on them and the pressures on these buildings. Let me take you on a snapshot, and with that in mind, to say and history of where all this process actually started. What you're looking at here is the two fathers in wind engineering. I hope you're able to see the slide in full. If not, just let me know.
Just put the full screen, Bhami. Once okay. When you put play from beginning, I think should be okay. Yeah, this is fine with us. It's the full screen.
You're able to see. Okay, great.
Yeah.
So back then in 1960s, this all happened. One of the founders of CPP, Professor Jack Cermak, he was working for actually in part of for the World Trade Center towers, the Twin Towers. And with him, who we can see is Professor Alan Davenport. So what happened essentially back then in 1960s in the lab, and this all happened in the CSU, the Colorado State University in Colorado, near to Denver. And the interesting thing was, what you're seeing looking at here is an overview of the proximity model with the Twin Towers. The key findings, or the start of the wind engineering era, actually started with these iconic towers back then. And one of our founders, Jack, he actually pioneered this process into it. And when you understand, when you start to look at wind engineering as such, as a process for design, one of the key elements you need to consider is a chain, and what we call it's the Alan Davenport wind loading chain. What you look at here on the screen is actually understanding the response of the structure to the wind. So these are the 5 links. What you see here, this one is the wind climate, the influence of the terrain. The wind climate, of course, is nothing but the climatic conditions. Influence of the terrain is with regard to your topography, the aerodynamic effects of the structure, the dynamic effects, which is your properties of the structure, which the structural engineer prepares, and the criteria. and the different criteria that built in. So it's a sequence of events. So it's like a chain, and the weaker the chain, as the saying goes, things become weaker. And we have to make sure each process or each chain in this 5 event is accounted for and understood in the wind engineering study. And the bigger picture, when you look at it here, this picture is in fact giving you a depiction of what all things come into picture and get involved with. Bluff body aerodynamics of the structure, meteorology, wind climate, the testing, structural dynamics, and also had a slide in there which says CFD. And this is something I'll touch base before we end, what we call in wind engineering, it's called CWE, computational wind engineering, whereas CFD stands for computational fluid dynamics, and CWE is a branch of CFD, and to what extent these things are used these days, and where you can, as a tool, as a designer, you can get to use this. So that's something I'll touch base down the line. What we are covering today is primarily on the facade pressures, but typically it also relates to the structural loads as well as the comfort levels. So where all it starts is we need to take to understand the data. So where is all this data coming from? So anemometers that's placed across the world. So at CPP, we have tons of data collected from airports across the world. Let's say in India, let's say in Dubai, in UAE, in Europe, and all parts of the globe. We collect these data in tie with meteorological associations, and we get them. And also, there is also big sources of information where we also have this from US Department in the States. And one of the key things before you understand wind as a process is also look at your topography. When you take a land piece and you look at it, and this is also very evident in codal provisions where we mention about urban, suburban, open country, and flat, different scale layers of topography of buildings and areas, wherein which you can actually assign different parameters of reference to it. And this is exactly what happens. The wind interactions with these areas, let's say urban interactions versus suburban interactions, are different. And this is exactly where we go in and we simulate in the wind tunnel. And then we go ahead and interestingly, we do that for every 10 degree. And as you will see in a short time, I'll show you the tunnel picture wherein which this process is actually done and how it's actually done. What you're looking at here is the boundary layer wind tunnel. So this is this is one of our newly designed tunnels in the US, in Colorado. And what you're looking at here is an ABL tower, what we call atmospheric boundary layer wind tunnel. And when you look at it, I have a picture that shows what these actually stands for. This is a sample of a project in the tunnel. You can see at the back there is a fan. Actually, it's black, and you're now able to see that. And then there are spires and roughness sheets to create the turbulence that's required, your surrounding model, the disk, and then your test model, which is our project, whichever it is that we're testing. What happens is that the surrounding model, that round circular disk, actually rotates every 10 degrees so that we can simulate what kind of a roughness parameter as the wind flows across. We need to capture the data. And also, if you look at the reference sheet, you can see a lot of patches on the sheet. So what these patches are, so this is something unique. What we have is called an automated reference sheet. Back in the days, it used to be manually. People used to change them to simulate all the different urban conditions, suburban urban conditions, but now it's all automated. So based on hilly terrain, non-hilly terrain, open terrain, we change of computerally, we can adjust them. So as the technology goes ahead, and the fundamental behind this science is nothing but the coefficients that get into the picture, in which we capture the CP data, what we call the coefficient of pressure. And this is essentially time history data that we capture and directional CP data. And that is something we then process out to calculate our pressures. And one of the key things here, or let me say, an understanding that's not most of the time people try to misunderstand when they imagine the wind tunnel testing is because there's a wind and there is an interaction and there's a building being tested. The building is tested with regard to the wind interaction on the surface, the architectural form of the building, like what you see in here. It is not actually replicating the climatic condition. Let's say that project was in New York. We are not creating a New York climatic condition inside the wind tunnel. So what happens with regard to the wind climate is a different piece. You remember that chain I showed you a few slides back, the Alan Davenport chain, the wind climate. So that's a key piece. So that is something we add on after the wind tunnel testing process. So once you capture the CP data, which is the interaction of the wind with regard to your surface, and then we add on the wind climate in the post data, and that's where we process all this airport data and all, and then we bring in to calculate out, to apply, to come up with the final pressures. So these are different coefficients of different surfaces. I think this is one of the key things within the process as we do this in the industry is we have designers where the results that come out of the project is sometimes, you know, the loads are going very high, or you need to fine tune it, you need to refine. So what we do is we go back to the wind tunnel, and in some of the cases we have these workshops where we go in and we tweak these buildings. So this is a very interesting architectural piece of work that we do, which is tapering, openings, cross section changes, softening. This is all in line with the architect and the structural engineer, both of them on the table. And this is something we do as a more like a workshop in some instances, and more on a feedback based on how the building, you know, behaves. And then we kind of, you know, bring down the responses in the structure. This is a small video here. I'm going to play. It has no sound, so you can see it's a tube that sits in, and what you're seeing right now is the wind is flowing in from the back, and you can see the cylinder. Look, focus on the red dot. Just focus on the red dot, and you can see that the cylinder is moving. Now, what you were just experiencing is something called as a crosswind loading, which typically, you know, codes doesn't take into account. And this is where that oscillative motion, when the wind is coming from one direction and starts to move, is something interestingly is captured, and that's also shown with regard to, and I will tell you in a moment why did we show you that, and what's the significance of that, and just before that, to visualize how the flow actually does happen, because you need some dye, in fact, to visualize it, because as you see, it's a fluid. Let me show you this video. So that what you saw was actually vortices being shed from the cylinder. So that is exactly what happens, and it's not visible to our eyes. So this is the process actually. And interestingly, there are different phenomena that happen, and one other one is the interference effects as well. Now we'll come back.
Bhami, I would like to interject. Can you play that video one more time? We couldn't get enough clarity on how it flowed. So if you don't mind, could you repeat that? Yeah, thank you.
Yeah, sure, Amit. I hope it worked this time.
Yeah, thank you.
Thank you. So what we saw was that dye in there shows the behavior of the vortices, what we call in aerodynamics, and interestingly, that's not visible to our eyes. And that is why now, if we go to the next video here, what it shows is what we've done simply is that cylinder that you saw earlier, we're doing the same experiment. What we're doing is we're just adding in a helical spring to it. And now what happens is that with this helical spring, if you notice that the motion actually dies down much. There's no sound for the video. So what you're looking at here is, again, the wind coming from the back, and that motion, if you look at the red dot again, that motion has been damped. And this is something, a very fundamental example, that if you look around anywhere, especially in industrial places where you can see chimneys, where these chimneys has helical springs going around it. This is one of the reasons, the key reasons behind it, that they do these helical springs in and around these cylindrical chimneys. Now, moving on, one of the ideas also, I'm bringing some CFD pics in here, and the reason behind that is also to show you what you saw on the die. We can also simulate them in the CFD to show you what is actually being shed. That is the vortex shedding process. So I'm just going to play one of the videos in there. It has no sound as well. So this is just showing you at a different dimension, at different speeds. The whole idea behind that observance is that you cannot really predict the flow. And the flow parameters really change from one object to another, one size to another. And that's where the beauty of the science of the fluid actually comes into picture. Quickly, this is what you're looking at here is different test configurations of pictures in which we actually have been in instances where we have to go back to the wind tunnel after the test process. We see the observation that the building is behaving very, very badly, and then we talk with the architects and the teams to see, we can probably camphor them, and we can sometimes when we close some of the open floors and things like that, and just do different iteration processes down it. And what you would finally get is something, this particular plot actually shows you that you can see a square section versus a square chamfered section and a rough circular section, all of them having a different route process of the impact on the loads, crosswind loads being reduced, and especially the circular one is way low. Quickly on to the labs, and this is where the interesting piece, and a bit mindful of the time. What we're looking at here is our labs where these behind the scene processes take place as we prepare the models for testing. This is an interesting project we completed in Dubai recently, one of the iconic address hotels with WSP. Now, for cladding pressures, as we measure these inside the wind tunnel, one of the things to understand, if you look to your left, you can see that as the flow comes from at one angle, there is a lot of wake created, and that wake generally has negative pressures, and that is something what we do as something called as a flow visualization technique. And this we especially do in workshops to show you, just like the dye process that we just saw earlier in the videos where we had the red dye. This is another way to capture to give you a feeling about how the wind actually flows in and around the corners. And looking at here, I'm going back and forth with the slides. You can see to the right at the top, what you're looking at here, nothing but it's the different, it's a positive versus the negative suction that you can see, and this is the time history data, that is the CP data that we are picking up from the transducers in the tunnel, and what we are doing and processing post the test. What happens is we grow them, we instrument them. This sometimes becomes a painstaking process for our builders in the lab because of the different features the architects bring in, different facade features as well, and then this has to be drilled to install with different sensors. You can see that that copper tube in there is actually different sensors that go in, and some of these had to be drilled and had to be fitted in with immense care. And that's a finished model in there. And now what you're seeing here is a spaghetti, in fact, if I may say. It's a Marina Bay Stands, one of the iconic projects that we have worked. Also, we're working on the new one that's coming up as well. So this, you can see the number of tubes that go in between below that for these pressures. So it's quite interesting amount of work that goes into it. This is at different forms, what we go through the process, and this is where I need to slowly bring in to show you what exactly, once the product is finished, what we do when we present the zone diagrams, our facade consultants get the pressures, the different pressures that's required. And this is exactly where the teams can go in and pick in which is the hotspots, if it's and actually design the facades in that part. And interestingly, this it also being done. Now, one of the questions that most of the time that comes is also, does it only apply to high rises? No. So especially with regard to the cladding, you can actually go and have an economical design with regard to the budget if you actually perform this process. Actually, even on a long span building which is completely facaded, because you are finding out where are the hotspots and where are the different zones where you can go and pick and work with the facade curtain wall consultant to actually help them narrow down the pressures. What you're looking at here is another way of presentation. We tend to, depending on our end user, we tend to incorporate different variabilities. You can see that after the fabrication, there is a meshing being done, and then it's being presented even in contoured colored forms. And this is one of the newly updated features where we actually tend to give emphasis on. Now, before we touch down quickly on the CW component, I want to quickly show you a newspaper cutting. So this is a project in UK. It's called the Bridgewater Place Junction. Very windy, noisy problem maker, and one person died because of that. There have been several incidences over the years, and what happened finally was that because of very high wind flow flushing in and gushing down, it was creating a funnel, and in this case a lorry was passing by and a doctor was killed, apparently. A very unfortunate incident. And then we got a call one night to actually go in and take to look at it to mitigate this process. So this is one of the comfort criteria, is what happened within a building facility, and we had to go, and this is what you see here is inside the wind tunnel. We have to bring in those mesh like features around the building to actually stop the funnel of wind. And then in some instances it really shoot up about 120 kilometers per hour. So quite an interesting thing that was happening. And finally, apparently the design team didn't account for it initially during the design process, and then this has to be fixed. And what you're looking at here is we assess them in different ways, which is looking at the comfort, what typically called as Lawson's criteria. How are your patrons sitting, standing, walking, business walking, uncomfortable, and we mark them in the tunnel during a reporting process. We also integrate them into different tools. This is one of our Wind Lab software that we use as well with the clients, where we can actually helps the end user, whoever it may be, to actually visualize it and use it in a 3D form. Now, one of the key things what we need to understand is there are different tools we can use all throughout when we're approaching. But in the industry, especially within the wind engineering industry, one of what there has been an agreement is the pedestrian comfort. Yes, you can start to use a CWE, which is a computational CFD process, to as vis-a-vis with wind tunnel, but not on the structural or the facade pressures for the cladding. The research is still ongoing, but it has not developed there to actually. The problem is with CFD, one of the key things is turbulence modeling, and turbulence modeling is not there yet to predict for your strength design and the facade pressure. So that is one of the key reminders I would ask you to take home, because we need always, as consultants and designers in the industry, we need to be aware of what is the right tool to use, and then especially with a CFD process, it's always what you give as an input is what you give as an output. It's garbage in, garbage out. So you have to be very wary of what the input that you're giving in. Before I conclude, some of these interesting iconic projects we recently concluded. Expo 2020, UAE Pavilion, Address Hotel, SRG with Killa Design, De Simone, Calatrava, all of design different teams that we have worked with recently. I think with that I conclude. Thanks for having me, guys.
Thank you very much, Bhami. It was pretty interesting because I've never seen anything that is that interesting, and there are so many elements about the facade. So I hope I was just going through the list of attendees. I have lots of friends who I've known personally for a very long time, and I was kind of happy to see that, and it was pretty interesting. A lot of people who I've known as well for more than 20 years are already on this particular webinar at the moment. So I'd like to just share screen with you guys for just a second. The whole model behind WFM Media is to be able to build an interface for the facade and fenestration industry across the world, and that's been our goal. And of course, from the world of facades that Zach has been doing for a while, we've been trying to make sure. So now, after a lot of effort over the last maybe more than a year and a half, we have been able to put content which is equivalent to maybe about a few thousands of hours of reading if you actually take time. I would just a second. Oh goodness, just a second, gentlemen. I'm prepared very well for this. Is my screen visible to you? Is WFM Media this visible to you?
No, you got to click sharing on top, and you got to select your.
One minute. Oh shit! No, I can't do it. I have to then lock down my screen because it's in a lock mode. So I will request Ahad if you can share your screen, but it doesn't matter even if you don't. So wfmmedia.com is a digital platform where we are trying to put everything together. Over the next couple of weeks, you'll be able to see a few hundred videos from seminars, from people who've talked about different subjects over the last 8 years in our journey at the world of facades. At the same time, we will be hosting these webinars across different subjects as time goes by, and there is a whole lot of content. So the idea behind WFM Media is to be that one center point of platform. So Ahad is just running the platform to you. We already have quite a few advertisers on board who have worked with us in the Window and Facade magazine. We have a 9-member team here at WFM Media, which includes editors, content writers, sales, and a lot more on technology, people who are with HTML, SEO. Every month, our ranking is increasing by about 200% because of the amount of data that we put on the site globally. So just to fill you in, we had 412 registered people on this seminar today. So I'm really happy for that so many people joined in and have attended. I am sure there must have been something to gain. I pass it over to Ahad now to let you have the question and answer session. Ahad, over to you.
Yes, so we've got some questions in. So I will just yes. So I will start with the first question for Mr. Mahesh. So there's a question by Mr. Ghosh which asks, for curved structures having a span over 100 meters, placed at a height of 100 meter plus, what are the methods of BMU that can be suggested? So I think he's asking for a curved building over 100 meters high.
See, goes from architect or
from Mr. Ghosh is the developer. He's from Forum Projects, Calcutta.
okay, great. See, the 100 meters height, we did one of the complex geometry in Chennai. Is it 17-meter cantilever and about the butterfly above is about another 10 meters, about 20-30 meters cantilever. Is a TCS Ratan Tata's iconic tower with a customer care center. Is the tallest building in Chennai, about on the seaside, and is tested for 9 kPa. I just show the image, share the screen to understand the complexity of this job.
Right, I'll just make you the presenter. You can have you can share those slides.
Yeah.
Yes.
See, this is a project we tested TCS Riseri Customer Care Center of TCS, tested for 9 kPa. You can see the 5 geometries. The cantilever of this is completed and withstand these 2 cyclones and the flooding. We did, I think I zoom in the images. We did a 5 different geometries. Look at this. This is a completed image. And you can see this geometry. We put upselling hooks. Actually, there is a heavy equipment of the required, like as I presented earlier, like car windscreen wiper equipment, like that inverted one, or the on the top of the parapet, and we can maintain it. But too expensive. And for such a cantilever, already the deflection on this cantilever structure is around 90 mm. On top of it, on the rooftop, we put this equipment. The structure has to heavily designed, and for such a condition, then the shaft is running on a core. The structure is standing on a core wall. So we decided to not to put these machines. Then we put upselling and retrieve system. So if you zoom in these images, you Google it and zoom in this TCS Research Tower. Every 1.2 meter square, every 1.2 meter square on this geometry, we provide upselling hooks. So that hooks you can lock and by both hands. Both hands you extend left side and right, you can reach to 1600 mm. So we design a hook of 1.2 meter. So any human being can hook on left or right or top to bottom, above or below. So we made such upselling system to maintain this geometry. Then we can finish the cleaning and maintenance. You can come down.
Right. There's another question for you itself. I'll stick on the BMU questions first, then we can go to the next one. How often does the BMU system needs to be inspected for maintenance? This is by Mr. Saxena, Shantwan Saxena.
See, there is a cleaning cycle of a building in every 3 months or 4 months. Okay. So at least this BMU system to be maintained every 3 months once for every 3 months to 4 months of the operations. And when naturally you use it, so automatically it's maintained like a car. You make it standalone and kept it, and after 1 year you want to come and maintain the facade, then every 3 months also you need to just operate and shut down this machine, because a lot of electrical components are there for operating, and mechatronics are there, and PLC programs switches are there. So the machine, so you need a periodical maintenance.
Right. One more question for you, Mr. Abhijit Erande. Do you recommend any BMU for a BMU system for a building with a height of 35 to 40 meters?
See, 35-40 meters definitely required, but depends on the geometry of the facade. Even you can do upselling hooks and maintain, or you can rent a machine and use it. So subject to your perimeter of the building and landscape allow you to use a cherry picker machine. If not, then you can rent a Davit or something. 30-40 meters is not a big complicated thing.
Right.
There's a lot of options you can explore and use it.
Right. Is there any NBC code or norm to govern the requirement of a BMU system? By Mr. Amod Kulkarni.
See, as far as I know, there is a codes on new NBC. I'm not sure, but there was a discussion going in the Indian Bureau of Indian Standards to implement this. And time being, all over the world, everybody is following EN 1808, because most of the machines are manufactured by 1808 and EN 7985 code. Even there's a codes and guidelines, American standard are there. American 230 is there, but that is mainly for heavy restraint, because America has a typhoon and other things, So most of the machines, the drum traction hoist or drum hoist or winches, mostly under EN 1808 and tested on EN 7985 only, globally, including China and everywhere, even Japan.
Right. We'll take some questions from Mr. Bhami. There's a question by Mr. Anil Kumar. What is the contribution of the different components of the Allen Davenport chain on wind testing? Any factors that play a greater role than the other ones?
Yeah. Well, that's a nice question with regard to, and was this from Krishna or this was from, because I can see a question popping from Krishna.
Right. So this is from Anil Kumar Thakur.
Okay. So with regard to the Davenport chain, there are key elements. So all of them, like I was indicating, with regard to wind climate, the terrain effect, all of them play equally key important factor. Now, I would say the dynamic side, yes, there is something very key, because the response of the building would actually, we can actually bring down a lot of cost. And when you start to mean the cost, the piling cost, and the whole throughout the structure, we can bring down the cost. And how we do that is something key. So what happens in the process is that once the testing is done, that is the data of the architectural 3D modeler, so that we go in, we fabricate, we whatever methodology we choose, which I didn't discuss in this, because that's a whole new chapter in itself in terms of looking at the different methodologies to test inside a wind tunnel based on what kind.
Think we lost you, Bhami. Your audio, we've lost you.
Can you hear me now?
Yeah, it's clear now. Yeah.
Okay. So what I was saying is, once the testing is completed, what happens is that the dynamic properties that comes out of the structural consultant, and that would be your mass, your MMI, and all that parameters, the frequency and the mode shapes. We look at them and we add that onto the system to understand the building response. And then what happens based on that, as output comes, the overall base moments and shears and moments, how these are behaving. Based on that, we go back and do a reiteration. And this reiteration is something very key, because this is where we also get a lot of question that, suppose I need to change my design a little bit here and there. What can I do? Do I have to do a whole retesting process? The answer is no, you don't have to do a retesting process. So what happens is that the test that we have already conducted, and you have a change in your dynamics, or we recommend that change, mostly that is what happens, and then, or you refine that in your drawing table, we would take that properties and then add on, that is, we would take that new set of properties and then add on to our data, and we go and change. And with regard to architectural, I should touch base, because this is also key. If we are not talking, if we are talking about a 1, 2, 3, 4 floor changes, depending on the shape and form of the structure, we may be able to adjust analytically. But in other cases, and as you know, as in other cases, what would happen is we may have to go and do a retest. And it's a judgment call, engineering judgment call, that we as consultants make to actually lower down the design loads, which saves cost.
Right. Yeah. The next question is by Mr. Rishikesh Patil. If there are 4 buildings in a row of 100-meter height each, situated around 20 meters from each other, is there a chance of wind tunnel formation and adverse effects expected of it?
Yes, indeed. So this is where the interference kicks in, effects kick in, one of the key part of it. And we don't know how these interferences kick in. And it is also a matter of the shape and form of not only your building, but also your neighbor. And that's why, if you recall, the disc trace I was showing you a while back, interestingly, it's how it is done is we have a 500-meter disc trace, 500-meter radius in full scale. So if your project is, say, at a point 500 meters from that's where it's well accounted to take in the immediate proximity behavior of the buildings surrounding you. And then the question comes, so that is the neighboring, let's say the 4 or 5 towers that's there, and it influences your building for sure. But one of the key things to understand is also what happens, let's say a kilometer or two, there's a development going. How do you account for that? There is a mountain there. How do you account for that? There's ocean there coming up. So what happens is that's where, if you recall those automated fetches, what happens is we go in and simulate that automated fetches inside the wind tunnel to go up and down, and depending on that, it's called reference blocks. So we bring in them and we change the characteristics of the flow dynamics inside the wind tunnel. So those inferences with regard to the proximity of the buildings surrounding you, we do different kinds of testing. It could be multiple configurations that we test in some instances. It is also, again, a judgment that we as engineers look into it as consultants, and with the design team we make. Thank you.
Right. I've given you a question from Pawan Iyengar. It's a little long one. You can just read through it till I ask Mr. Mahesh few questions. I hope it's on your screen, Bhami, from Pawan Iyengar.
I'm
yes,
just looking.
now,
I'll just read the question.
You can just read. By the time I'll ask a few questions on BMU to Mr. Mahesh. Mr. Mahesh, there's a question from Rahul Singh. Is ASME 120-1 for facade access system, which standard is for BMU access for USA? I think your mic is mute. I think you're on mute.
Yeah, the same American standard, that's what I said earlier in the response to the other gentleman. That code, the restrain is a higher restrain load than EN 1808. So for restrain perspective, we follow the American code. For BMU and hoists and winches and other beam equipments, we follow 1808 and EN 7885.
Right. There's a question from Rajesh Virdi. What is the solution or suggestion on meeting the established criteria of EN 180802-015 on effective usage of cradle restraint system, intermittent sockets, anchors for low profile davits, and the monorail as the FAE for building more than 40-meter height with cradle operation from the ground?
See, self-climbing cradle from ground, you cannot have a restraint socket because when you go up and come down, then you cannot take it out the thing. So only option, so that kind of above 40 meter, you have to go for BME system when restraint requirement. When below 40 mm, we can go for self-climbing cradle, which is not restraint not required. But exceeding 40 meter height, every 10 meters intervals, you require a restraint.
Right. We'll take one question for you. Last one before we move to Bhami. Do we have Indian manufactured BMU systems or they need to be imported? This is from Shalini.
See, the Indian manufacturers, there are a few companies available in India where definitely they can all the steel fabrication equipments, the tracks and the systems, everything they can manufacture locally. And this should be treated because is on the roof and should be hot dip galvanized and treated properly for withstand these weather conditions. But add on to that, all winches, hoists, and all the sensors, everything, they can import tested one in compliance to EN 1808 and EN 785 tested. They can import and integrate into the design and systems. End of the day, everything, even the assembled, semi-assembled and imported or assembled and imported here, and they're doing it. They have to fully tested factory test, and they have to do on-site testing also and commissioned. If they do not do factory test, you will end up with the problems at the site. But more for complete BME for high rise for 100 meters above, the integrated BME system mostly fully imported, only workable.
Okay, great. Now we'll go to Bhami. Bhami, you can read Pawan's question and also the answer.
Yeah. Sure. So I'll answer two of them because I also saw Krishna's message as well.
Yes, right.
Coming in. It's a very good question.
You can just read the question out and answer them.
Yeah, sure. I'll start here with the first one. Can you shed some light on incorporating the dynamic effects of Davenport into the wind tunnel? For example, how do you incorporate these with regard to measuring accelerations? So now measuring acceleration is a very interesting thing, and this was out of scope of our discussion as well. But this is quite an interesting one because there are so many stories behind it. Because acceleration is a comfort criteria, not a safety criteria. Now, when you look at it, let's envision, let me take you to New York for a second. Once we go, you can see it's very densely populated. Sorry, when you say very, of course, very dense, very slender buildings in New York. And what happens is that with these slender buildings actually, and who owns them at the top, let's say penthouses, these are probably very wealthy people. And there have been several instances where when the designers haven't actually accounted for a proper acceleration criteria. And what is all this acceleration? So it's for the viewers who hasn't heard about this before. The thing is, you are sitting in a building as such, let's say in your penthouse, drinking a coffee, and you're walking around, you feel the building is moving. You feel it's slightly moving, swaying. Whereas, and would you live in that apartment? Would you live in that penthouse? I wouldn't. I would feel, and it's a perception. So the research has shown that person A to person B to C, it differs how you perceive about that motion, and there's immense amounts of test research being done on that. And we account that for as well in our studies, and I'll mention in a bit how is that done. But versus an office space, you're moving around all the time, you're discussing, you're in meetings, and so the criteria changes from office to residence. That's one of the key things in these accelerations. And these measurements are done nothing but from the structural engineer. We take those data, we take those properties, the dynamic properties of the building, and then we plug into our system after the wind tunnel test is done to understand what kind of a milli-G. It's reported in milli-Gs. Typically 18 milli-G is kind of a threshold, and then from there it goes on to 25 for offices and so on. But this is the key thing is you always need to take into account for accelerations on a tall building. But in low rises, this is not a concern at all. But in tall high rises, that's with Krishna's here, and I think I'll go to Pavan's. Would you like me to read out?
Yes, please.
This is when a building is designed, the architect does the design based on the requirement of the builder or organizer. The planning is done. After the same is done, after the same is done, the same to be decided to have an opening or closure due to the excess solar factor, also due to the type of wind gust, which could be better. If they knew of the wind shape of the planning needs to be done, do we have a method where based on the topography, we could suggest the basic shape and the path, or for the architect in designing, help in designing later, we could consider the same for the wind tunnel test. Okay, so Pavan, very nice question. Now, this is an interesting one wherein which we come in. So we have the concept, we have the schematic, and we have the DD. Now, typically as wind consultants, we come in somewhere on the SD stage, and always we recommend when you take a larger development or a larger tower development, concept to pre-concept, if you bring in consultants like us, one of the key advantage to it from a cost perspective is you can go in, and we, especially with regard to the thermal comfort part of it, the pedestrian, the pattern comfort part of it, we would make our observations, and that is actually a preliminary, what we call as a desktop assessment, wherein which there is no wind tunnel involved. It's all analytical. It's based on our experience from the past, and we take that process, and we walk hand in with you through that process. And then what happens is that based on that preliminary input, and we do this all the time, with that preliminary input, companies, the clients, the architectural design team and the structural design team, all of them can go back to the drawing board and formalize them for the SD design.
Right. I'll take a BMU question before we get back to you, Bhami. So there's a question here for Mr. Mahesh by Mr. Nitin Patankar. In a 100-meter building, how many restraint pins or intervals required for safe operation? I think your mic is mute.
Sorry. After 40 meter, every 10 meter required based on the width of the cradle. For example, the cradle is 2.5 meter or 2 meters or 3 meters. So it depends on the cradle width. You need to put the restraint pin at every 10 meter. Every 3 floors, 1 restraint required after 40 meters height. Below 40 meters, no restraint required.
Right. There's another question. What are the external design parameters to be considered for the facade outward layout?
Means inclined or outward?
I'm not sure if the question is complete. What are the external design parameters to be considered for the facade outward layout?
Outward layout. Maybe he's talking about the projected facade elements.
Yeah, probably. I'm not sure.
So this depends on the cantilever projections or outward inclinations. If it's outward inclination, then you need a guided roll, guided restraint to be mounted onto the facade mullions joints. You cannot go with the restraint points. Then If it's not too projected out or not too projected inclination, then there are different systems available. Pantograph cradle available, up to 4 meter reach can be do. Articulated cradle can be done. Then swivel cradle can go up to 1.5 meter. So there are different systems available. You can reach to the projected facade and recess. But depends on the inclination and the geometry it need to be addressed. Is very subjective. So if you wanted something, you share some images, we can respond to that.
Right. I have a question for the both of you. So how does a facade engineer and a wind engineer collaborate together early stage of a project? Who gets involved first, and how is that both of you can work hand in hand in executing a project together?
I think Bhami, you go first.
Yeah, thanks, Maheshji. I think this is a very interesting question, because this is something we really need to look at, because this is, I would say, in my experience in the past, this collaboration is way less, and it's nothing at any one side's issue, because this is people are busy within their stream of mind. And what happens is we typically, our client contact as such is the architect or the structural developers, structural engineers or the developers. So these three people approach us. And then what happens is that there is also the facade consultant, the curtain wall consultant also in there using our product as such, as the package of the report. But that cross interaction, I would say, to be honest, is very minimal. But we always tend to strive to have that that road open to discuss and have a feedback between both of us. And because it's all in, for the end client, when you look at it, it's let's say from an economical perspective, we can bring down costs with a further collaboration.
Right. I think we are running out of time. I'll just call Amit to close today's session. There are a lot of other questions. There are 25 more questions. I'm going to share that with you guys so that you can directly reply to the people's questions. So I can ask Amit to end today's session.
Thanks, Ahad. Mahesh, thank you very much. Thank you, Bhami. First of all, stay safe, stay at home, and we'll, from Team WFM Media, my whole team, I'd like to thank them for working hard to reach out to so many of you to have been able to come attended this wonderful webinar. We shall come back again in the next couple of days with a couple of interesting subjects. Keep you informed and stay safe. Dhanyavad. Thank you. Shukriya. Khuda Hafiz.
Thank you.
Thank you to all. Be safe in this COVID-19. We will overcome in this situation in coming weeks.
Sure.
We have no choice, my dear friend Madanna.
You too, man. Thank you.
Take care.
Thank you to all participants.
Bye-bye. Thank you.